Okay, good morning. Here we go, or good afternoon, as the case may be. It is May 13th. Little preview for the week before we get into what we're actually doing today. Kind of a weird week with map testing, spring map testing going on. So for today, no effect on sixth grade because we are, except that we don't have computers because they've been given up to seventh grade. So that they can go ahead and complete their testing session. Academically, though, no change for us, regular schedule. For tomorrow, second period will not meet, neither will third period. Core Plus More classes will go directly to, at second hour, you go to your Core Plus More class for map testing sessions. Going to be block period second and third together with your Core Plus More teacher doing your map testing. I want to say the first session on Tuesday is going to be math. And then we'll follow that same schedule again on Thursday. So not on Wednesday. Wednesday we'll do our regular class schedule, but then on Thursday we're going to be back to map testing, doing the schedule for that. I believe that'll be the reading then. So that'll be again going to your Core Plus More teacher second period. So second and third block schedule, and then regular schedule rest of the day on Thursday. Also for today, if you're in the afternoon classes, then this is the only way that you're seeing me, assuming that whoever comes in to help us out shows this video, because I'm in a professional development training. The other science teachers and I are over in the professional development room doing a study with Discovery Education. So that is what is going on today and this week, kind of a hectic schedule. Let's get into what we're starting with today. I do want to mention there will be a chance for corrections on this test from last week. This should look familiar, this side and this side, similar to what I did with the formatives, and then some of those were stamped, please correct and return. I'm going to be actually grading these in highlighter, and then on Wednesday should be the opportunity with the weird scheduling stuff. We're going to move it to Wednesday. Then we'll take a look at correctives on this or any other work you might need to correct. So taking a look at this stuff at that point. I do want to throw that out there. If you haven't taken that test yet, if you weren't here on Friday, then we'll get that sorted out as well. For today's assignment, we're looking at this activity of mass versus weight. Because we are running short on resources as we get to the end of the school year, I wanted to share it out on Google Classroom, but like I said, computer's not available today. So instead we have a class copy of the reading, and then on the back of the reading is a class copy of these questions. So you're gonna have to write your answers to your questions on a separate piece of paper. I know that sometimes that's frustrating, but I think we can get through it. So let's go ahead and take a look at this page together, start of the packet. Actually, I'll go ahead and hold one up so you guys can see it and get an extra copy. Okay, so a good learning strategy can actually be to take a look at the questions first. So I am going to go ahead and start you guys by previewing the questions, and then we'll read through the reading portion together. So here, taking a look at the questions. I'm just going to hold those up right in front of me. Complete the questions after reading about mass. Mass is blank. If a bike and a truck were traveling at the same speed, which would be harder to stop? Explain why. Is mass the same as size? Can two things be the same size but have a different mass? Give an example. Weight is a measure of how much blank is pulling on you. If you went to the moon, would your mass or weight change? Draw this diagram. So since we're doing this on our own piece of paper, doesn't matter if the diagrams are on here. Draw this diagram with you on Earth and the moon, and you just floating in space. My weight on Earth is around 560 newtons. My weight on the moon is around 90 newtons. My mass is always 56 kilograms. So we'll go ahead and work on conversion factor. You guys can try to figure that out for what's going to work for you. And then what unit of measurement is used to measure weight in the diagram above? What unit of measurement is used to measure mass in the diagram above? And then, of course, we cite our source. So that is what that page looks like. Let's go ahead and jump back to the start. Mass versus weight. 3 goals for today. I can define mass in terms of inertia. I can define weight in terms of gravity. And I can explain the difference between mass and weight. So that is our objectives for today right there, close up. That is our objectives. I know I usually get those sooner in the intro. Okay, mass. A measure of the amount of material in an object or the measure of an object's inertia, directly related to the number and type of atoms present in the object, does not change with the change of location or shape, you have to remove atoms to change mass. It's measured in grams. Force equals ma. It's the net force. And then weight, the measure of the gravitational force acting on a body's mass, or the force Earth exerts on an object. Weight equals mass times acceleration of gravity. Weight changes with location. On the moon, in space, slightly with ease locations. That's Earth's locations. That's what ease locations are. Weight is measured in newtons on a scale. Gravity equals acceleration of gravity, meters per second squared. It's 9.8 meters per second squared for the planet Earth. So it's going to be a little bit different sometimes other places, but for the planet Earth, 9.8 meters per second. Turning over to page 2. Okay, why does a scale measure in grams? Unit of mass. The relationship of mass and weight on an object while close to the Earth's surface is special. The only force acting on the object is the pull of gravity. We've talked a lot about how gravity is a constant. So the force of gravity equals mass times acceleration. So your weight is going to be the same acceleration on Earth for all objects in the same spot. And I talked a little bit about how it could change a little bit depending on where you go. So here are our definitions. I'm not going to read through those so you guys can see the comparison there. I'm going to go ahead and jump up to the next page, which is the cartoon. Right here. I'll give you guys the color version, actually. Neil, I've lost so much mass since coming to space. Buzz, you didn't lose mass, you're on the moon. Okay, so that's our original men on the moon, Neil Armstrong and Buzz Aldrin, trying to understand the difference between mass and weight. So that's what we're looking at with the cartoon there. I'll go ahead and leave that up on the screen so you guys can see it. We'll be working together, working on those questions, trying to understand these things, trying to give some examples of how shape doesn't change your mass, how movement doesn't change your mass, and so we'll actually do some movement, do some change of shape, that kind of thing. So like if we're looking at the mass of my hand's very big right here, especially on the big screen. Now it's smaller because it's a fist, same mass, same number of atoms in my hand. That's kind of the stuff we're looking at today. Hopefully that makes sense. These sheets are out on the tables, and so we're going to be taking notes on our own pieces of paper and trying to understand these concepts of mass and weight. Happy Monday.